What goes through your mind when you think of pavement repairs? If you're a motorist, you're probably thinking, it's good they're fixing the roads, but I hate the traffic it causes and the long time it takes to get done. But if you work for either the local Department of Transportation or a road construction firm, you could be thinking, what is the fastest yet most cost-effective and safest way to get the job done? With a focus on reducing construction time and costs while increasing worker safety, advancements made by the precast concrete industry have introduced better ways to satisfy both concerns.
Recognizing this, NYSDOT decided to use precast on the Route 495 restoration project. The contractor was Beauvais Industries, who elected to use a local producer, Roman Stone. They have a proprietary system appropriately named Roman Road Systems. Route 495, or the LIE, is a heavily trafficked highway on Long Island. It has 3 lanes in each direction, with a 4th HOV lane, and allows truck traffic in the right and center lanes. Although in the section restored, there is no HOV lane. Repairs were made in all 3 lanes in both directions and covered a total of 4.2 miles. As such, all work was performed at night during a 7-hour work window between 10 p.m. and 5 a.m. Here are some other facts and figures from the job. Total number of precast repair sites, 410. Average thickness of pavement, 9 inches. Approximate width of lanes, 12 feet. Lengths of panels installed, 6 feet to 16 feet long. Total surface area of precast repairs, 4,022 square yards. Total volume of precast installed, 1,052 cubic yards. As with most precast pavement methods today, it is a 3-part system. 1. Remove the existing pavement. 2. Prepare the excavation site. 3. Install the new panel. However, in this case, a unique polyurethane injection method used to bed and level the precast slabs reduces the amount of substeps required. This material is called HDP for short. Besides the normal excavating equipment needed by the contractor, the following special items are supplied by the manufacturer. A saw-cut template to mark out the excavation site, a scratch template to check the depth, a drill template to gang drill into the existing pavement, temporary slabs, HDP injection equipment and crew. The first step is to remove the damaged pavement. Using the supplied saw-cut template, the desired area is marked out to ensure it matches the dimensions of the replacement slab. The marked out areas are then saw-cut and the pavement removed using the standard NYS lift-out method to minimize disturbance to the subbase. Temporary slabs can then be used as an added advantage to attain higher installation rates. This is because it allows the contractor to prepare additional sites before the next crew starts. The second step is to prepare the site to receive the finished slab. After removing the temporary slab, the supplied drill template is used to mark where the holes will go into the existing pavement. These will be for the dowel bars that are used as load transfer devices. Then the gang drill goes to work. Next, the subbase is prepared. Because the injection crew does the actual bedding and lifting of the slab, a minimal amount of work is needed by the contractor. In this case, the removed pavement was 9 inches thick. Therefore, unlike the temporary slabs that were the same thickness, the manufacturer produced finished slabs that were only 8 inches thick. That is because the remaining 1 inch is taken up by the HDP. This will hold true for any thickness of highway. Depending on the location, the manufacturer will precast the slabs to the same thickness of the existing pavement minus 1 inch for the polyurethane. As seen here, workers used a supplied scratch template to make sure the depth of the excavation is uniform throughout. Again, emphasis is placed on using the proper equipment to ensure a proper fit. The third step is to install the finished slab. Using a crane, panels are set into the excavation. Note the holes in the sides of the slab. These are the voids that were formed during production to accommodate the dowel bars. The hash marks over them help guide the contractor to break away the thin top skin needed to expose the voids. However, to further improve efficiency, this process will be accomplished during a later shift, as the 1 inch of top material is enough to support traffic while the road is reopened. Now the HDP crew goes to work. The same care that went into manufacturing the slabs goes into the injection method, and both have been QC tested prior to installation. There are many advantages to this injection method. The HDP is hydro insensitive and can be used in almost any temperature, rain or shine. It completely stabilizes the subbase and eliminates settling of the slab. All work needed to set up the slab to grade is accomplished by the HDP crew. Note the polyurethane as it comes up the sides of the slab. This is to ensure uniform support under the slab. Any excess material is simply cut off and removed by the HDP crew. At this site, two 12-foot by 12-foot panels were installed in adjacent lanes, showing that this system can also be used in continuous pavement applications as well as intermittent repairs. The next part of this step is to install the dowel bars. The contractor now uses a jackhammer to break away the thin skin of concrete to expose the voids. Once cleaned out, the dowel bars with expansion caps are placed into the voids and pushed into the holes of the existing pavement. Finally, a fast-setting grout is used to cover the voids, and after an hour of curing, the lane can be reopened. If required, a silicone sealant can be used around the perimeter of each slab by an approved vendor. On this project, the contractor was able to set as high as 18 slabs in one 7-hour shift. Larger numbers can be achieved in cases where the job and contractor can support more than one HDP crew. Perhaps the best insight to the advantages of any precast system is to hear from those who actually used it. So here is Frank Oliva, the project super who was responsible for much of the success of this project.
Hi, I'm Frank Oliva from Bove Industries in East Setauket, New York. I was the job super on a recent New York State DOT project which required the replacement of portions of the Long Island Expressway with precast panels. We decided to use the Roman road system because we felt that this system required less setup and finishing time. This will allow us to achieve the high installation rates required by our aggressive schedule. We would definitely use this system again and would recommend it to contractors for future projects with precast concrete pavement replacements.
So in review, precast pavement repairs can reduce the time the traffic is disrupted, reduce the time workers are exposed to danger, and reduce the amount of on-site inspection. These reductions equate to reduced costs while increasing the life cycle of the repair as well as worker safety, a high priority shared by us all. On behalf of Roman Stone, this is Lane Urbis. Thank you for your attention.